Today our topic is solving equations and inequalities. So our learning targets are how can I solve equations and inequalities, and how can I solve a system of linear equations. Again, this is all review from our 8th grade MCA standards. Solving equations / inequality steps. If we remember these, number 1 is distribute. Number 2, combine like terms. Number 3, get variable to one side. Number 4, undo addition and subtraction. Number 5, undo multiplication and division. Difference. What is the difference between solving equations and solving inequalities? If we remember this, the one difference is when we divide or multiply by a negative, we have to flip the inequality. And we will have some practice with this, but make sure when you divide or multiply by a negative, you flip the inequality. So it's the one difference between equations and inequalities. Solve, just some practice solving. So for the first one, we have parentheses, which means we have distribution. So we take the -2 and distribute it. -2 times 1 is -2. -2 times -7n is positive 14n. Combine like terms. We don't have any like terms to combine, so we get our variables to one side. I like to move the smaller one because then I don't have to work with negatives, so 5n is smaller than 14n. So I'm going to move 5n by doing minus 5n on both sides. Bring down the 34 equals -2. 14n minus 5n is 9n. Get the -2 over to join the 34 by adding 2 to both sides. We have 36 equals 9n. Lastly, divide both sides by 9. Undo this multiplication here, and we have n equals 4. Alright, so what I would like you to do is pause the video right now and try the second problem on your own. And then resume the video to see if you got it right. Parentheses mean distribute. Distribute the 2. We get 8x minus 6 minus 8 equals 4 plus 2x. Combine like terms. -6 minus 8 is -14 equals 4 plus 2x. Make sure you bring down the 8x. Get your variables to one side. Undo the plus 2x with a minus 2x. You need those railroad tracks. Make sure you draw them in. We have 6x minus 14 equals 4. Undo subtraction with addition. Add 14 to both sides. We have 6x equals 18. Undo multiplication with division, divide both sides by 6, and you should get x equals 3. Solving inequalities. So solving inequalities is very similar to solving equations. Just have an inequality symbol now. Distribute the -3. -3x minus 6 is less than 9. Undo minus 6 with a plus 6 on both sides. We get -3x is less than 15. Divide both sides by -3. Now this is where we have to be careful because we're dividing by a negative, which means our inequality symbol is going to flip around. We have x then is greater than 15 divided by -3 is -5. We do need to make sure we graph our solution, so put -5 in the middle. One number to the right, one number to the left. There is no equal to, so it's an open circle, and we're greater than. -4 is greater than -5, so we shade to the right. The second example, if you notice, we have the absolute value inequality, which means we have those two cases. So we take the piece in the middle, -2x plus 1 is less than 7. We keep it the same. We just really removed these absolute value bars here. For our second situation, we're going to keep this piece in the middle, -2x plus 1. However, we're going to change the less than to greater than, the +7 to -7. Okay, so that's the big difference. We have that second situation where we have to flip around this inequality sign and flip from positive to negative. Solve both of them. Undo +1 with -1. We get -2x is less than 6. Divide both sides by -2. And we get x -3. We divided by a negative, which means we have to flip our inequality. So we have x is greater than -3. On our second inequality, solve it the same way, -1 on both sides. We have -8 and -2x. Bring down your greater than sign. Divide both sides by -2. We get x and 4. We divided by a negative, which means we flip our inequality from greater than to less than. So we have two pieces here. We have x is greater than -3 and x is less than 4. So we need to graph both of those. So make sure we get 4. Not quite enough lines here to go by 1, so we're just going to have to add in an extra line there to get -3 on the graph. Now, we'll start here with x is greater than -3. Open circle because there's no equal to piece, and greater than means we're going to the right. And then when we do x is less than 4, we have an open circle at 4 because there's no equal to, and 3 is less than 4, so we're going to go to the left. They meet in the middle. If we remember, this is a between graph, which means the word and goes in the middle of our two inequalities. If you need extra support with this is all in Chapter 6. You can rewatch the Chapter 6 videos. Last piece is solving linear systems. So we have 3 methods for this. We have graphing. So you would graph the 2 lines and find the piece where they intersect, and that would be your solution. We have substitution, which we are going to review today. And the last one is elimination, which we are also going to review today. All right. For substitution, if we look at our first example, it fits very nicely for substitution because we have our second equation as y equals something. So y equals -5x, which means whenever I see a y, I can replace it with -5x. So here in my first equation, I see y, so I can make that substitution. So we have x plus 3. Everything stays the same except for that y, which we're changing to -5x. Continue the equation, equals -28. So in red, you can see where I made the substitution. Now we just need to solve for x using our solving equation skills. 3 times -5x is -15x. Bring down the x. And equals -28. Combine like terms, 1x plus -15x is -14x equals -28. Divide both sides by -14, and we get x equals 2. However, when we're solving a system, our answers are a coordinate point, which means we need our x variable and our y variable. We have x. We know x is 2. We just solved for that. Now we need to know what's y. So using this equation, we know y equals -5 times x. So now that I know x is 2, I can say y equals -5 times 2 instead of x. -5 times 2 would be -10, so y equals -10. Last example, we have a good example for elimination. And the reason why this is good for elimination is because they're both in standard form. When two equations are in standard form, it's really easy to use elimination. So first off, we need opposites. We need two variables that will cancel out. So if I look at 4x and 2x, if I multiply 2x by negative 2, it becomes negative 4, which is opposite of this positive 4 here. So distribute the negative 2 to 2x, and we get negative 4x. But we have to multiply the whole equation. We can't just change the one term. So negative 2 times negative 5y is positive 10y. And negative 2 times positive 1 is negative 2. We're going to rewrite that top equation below. 4x plus 3y equals 15. And then we are going to add the two equations together. Negative 4x plus 4x cancels out because they're opposites. 10y plus 3y is 13y. Equals negative 2 plus 15, which is 13. Divide both sides by 13. And we have y equals 1. Now again, for our solution, we need both x and y. We know y is 1. Now we need x. Choose either equation. I'll take the top equation. 4x plus 3y equals 15. Put your value in for y. 4x plus 3 times 1 equals 15. 3 times 1 is 3. We have 4x plus 3 equals 15. Undo plus 3 with a minus 3. We get 4x equals 12. Divide both sides by 4, and we get x equals 3. Add that back up here to your coordinate point and circle your answer. All right, just a last little piece. Just reviewing the different types of solutions. We can have one solution where the two lines intersect and we get a coordinate point for our answer like we did in the last two. We can have no solution, which is parallel lines, and we would get a false solution like 4 equals 7, which is not true. And then we could have infinite solutions, which means they graph to the same line, and they would give us a true solution like 0 equals 0. Again, if you need extra support with this, all of this is in our Chapter 7 videos that we did this year. Thank you for watching this video, and please subscribe to my YouTube channel.